Everyone, today my team and I will be presenting our project titled IoT-based Smart Fish Farm. I'm Cheyenne, so I'll be sharing how our system uses Internet of Things technology to support sustainable fish farming and contribute to the United Nations SDG 14 Life Below Water. So, the IoT connects physical device using sensor and communication technology. This device collect and share data in real time, helping people make smarter decisions while saving energy and reducing waste. IoT plays a big role in achieving the SDG by providing innovative, data-driven solutions for issues like hunger, clean energy, and sustainable cities. Our smart fish farm monitoring system is a great example. It helped achieve SDG 14 by making aquaculture more efficient and eco-friendly through automation and real-time monitoring. So here are the key points of our project. First, IoT helps connect devices to improve efficiency. Second, SDG 14 focus on protecting life below water. Third, our project supports sustainable aquaculture by promoting cleaner, smarter fish farming practice. And finally, our smart fish farm system monitor fish health and the pond environment to maintain the best condition for growth. Our smart fish farm monitoring system is designed to make pond management easier and more efficient for fish farmer using IoT technology. It's powered by an ESP32 microcontroller connected to the sensor that monitors temperature, pH, and oxygen level in the water. The ESP32 sends this data to a cloud platform or mobile app through Wi-Fi. If the water quality changes, the system can automatically activate the aerator or feeder and send alert to the farmer. This helps solve common challenges like poor water quality, overfeeding, and high maintenance costs, all while saving time, reducing labor, and promoting sustainable, eco-friendly fish farming. So I'm done for my part. Thank you.
Thank you, Cheyenne. Now, why this IoT device? This IoT device is designed to support agricultural farms by using smart sensors and automation to monitor and maintain healthy water conditions. This device combines ESP32 microcontroller technology, sensors, and automated feeding or monitoring system to help fish farmers manage their ponds more efficiently and sustainably. This device is chosen because aquaculture often suffers from poor water quality management, overfeeding, and high maintenance costs. By introducing IoT automation, it helps farmers reduce manual labor, increase fish survival rates, and promote eco-friendly practice. Now, how does this device work? This system operates using an ESP32 microcontroller connected to a series of sensors and actuators such as temperature sensors, pH sensors, and dissolved oxygen sensor. These sensors measure the water quality constantly. The ESP32 microcontroller will then process the information and send it to a cloud platform or a mobile dashboard. This process requires Wi-Fi, so farmers can monitor the pond condition remotely. The system will trigger aerators automatically to increase oxygen level if the water quality falls below safe level. It will also send alerts to the farmer to notify them. The ESP32 has also an automated feeding mechanism installed and can be activated by sensor data or a program schedule. It will also help collect and store data for analysis so farmers can analyze the patterns to enhance feeding and cleaning cycles. Let's talk about ESP32 and its purpose to the community. The main purpose of ESP32 is to enhance aquaculture efficiency and sustainability through automation and data-driven control. It allows fish farmers and small-scale users to manage their ponds more effectively by saving time and energy. It provides a variety of benefits to the community too. First, the ESP32 help enhance aquaculture efficiency. It allows real-time monitoring so farmers are able to detect poor quality early. This can help prevent death of fishes and food waste. Moreover, the microcontroller can also help reduce cost and labor. Automated sensors allow the system to be automated and minimize the need for manual check. Thus, farmers can save time and manpower. Next, high productivity. ESP32 can increase productivity by constantly monitoring the pond to ensure optimal growth condition. As a result, fish can grow healthier and yields can be better. Furthermore, the microcontroller supports local economic growth. It helps local communities to maintain sustainable income by providing a way to produce fresh products that lowers operational costs and manpower. Lastly, it can also help improve environmental awareness in the community. It encourages farmers to adopt eco-friendly technology. This can help promote sustainable aquaculture in the community. Now, how does this system help achieve life below water, which is the SDG 14? This IoT aquaculture system fully supports the goal of the SDG 14 by focusing on conserving the sustainable natural resources. It aims to protect marine life from overfeeding and pollution by having sensors to track and analyze the water quality. It achieves this by preventing overfeeding of marine life. It has an automatic feeder that will dispense the correct amount of food required. This can prevent food being left over and decomposed in the water. If food is decomposed in the water, it can cause oxygen depletion and water pollution, which leads to the death of marine life. The ESP32 also helps improve water quality in the pond. It does this by constantly monitoring the pH level, temperature of the water, and oxygen level to make sure that the pond stays within a safe range for fishes to live. When oxygen or pH level is not optimal, aerators will turn on automatically to alert the farmers. Besides that, it helps the community by reducing water pollution. It can prevent leftover waste and prevent the use of harmful chemicals. Moreover, the microcontroller collects and stores data. Farmers can use the data for long-term resource management by analyzing it. This can promote sustainable aquaculture by balancing productivity with environmental protection. The last benefit is obviously protecting aquatic life. This system helps prevent fishes from dying by sudden change in pH level or temperature.
Good morning or good evening to everyone. My name is Yang Lin. Now I'm going to talk about what is ESP32. Let's talk about the ESP32 Room 32, which is the main processor used in our smart fish farm monitoring system. This chip collects real-time data from sensors like temperature, pH, and dissolved oxygen, then processes it and sends it straight to the cloud for monitoring. There are 4 features about this processor, which is core architecture and performance, integrated connectivity, critical I/O for monitoring, and power management and suitability. Here is a detailed description about the specification of ESP32. The ESP32 was chosen because it fits really well with what a smart fish farm needs. First, it uses very little power. It can sleep most of the time and just wake up every few minutes to check the water, which is perfect when the device runs on battery or solar. Second, it already has Wi-Fi and Bluetooth built-in. That means it can send data straight to the cloud or to a farmer's phone without needing any extra modules or long cables. And lastly, the ESP32 can handle real-time tasks. It reads sensor data and can react fast, like turning on an aerator when oxygen drops. Since it has 2 cores, one can focus on the sensors and the other can handle the networking at the same time. Next, the ESP was chosen after comparison with other prominent CPUs. It is faster than the Arduino Uno, has more memory and includes built-in Wi-Fi and Bluetooth. The Uno simply lacks the power and connectivity required for a smart fish farm. STM32 processors are as fast and efficient as ESP32, but they lack built-in Wi-Fi or Bluetooth, making setup more complicated and power-hungry. Then there is the Raspberry Pi Zero W. It's more suitable to a little computer, but it consumes a lot of power and very excessive for something as simple as fish tank monitoring. So this is why we choose ESP32 as our main processor. That's all for me. Now I will pass it to my teammate.
Thank you, Yang for a wonderful presentation. Now we are going to discuss about processor. The ESP Room 32 works as the brain of the smart fish farm system. It reads sensor data like pH, temperature, and dissolved oxygen, then send that information to the cloud using its built-in Wi-Fi. It also controls key farm components like water pump or feeders based on the readings. Thanks to its dual-core setup, it can handle sensor, task, and wireless communication at the same time without lag. It's also power efficient, which makes it suitable for continuous use in remote farm environments. Next slide. The The processor has a clever memory system that take care of both power and performance. It has 520 kilobytes of quick SRAM for processing live data and 448 kilobytes of ROM for storing system level code. The fish farm firmware and log file for keeping track of prior sensor data are stored on the 8 megabyte external flash drive. The usage of RTC memory make it good for long-term monitoring. This memory preserves the last sensor reading even while the device is in deep sleep, so it wakes up ready to continue without losing crucial data. It's dynamically managed memory to prevent crashes and waste, which is very important for a system that is anticipated to work in the field for months. This memory structure works together to allow real-time computation, efficient storage, and dependable operation with as little power as possible. Next slide. The ESP32 has 12-bit ADC that can read signal from up to 18 analog input channels. This make it great for reading signals from water quality sensors like pH, dissolved oxygen, or turbidity probes. This let the system turn voltage output into digital data with a lot of accuracy. The chip also has up to 34 GPIO pins that may be set up to receive signal from digital sensors like temperature probes or water level switches. This makes it easy to handle many types of input. The ESP32 has a GPIO pins that can turn on relays, which can then turn on pumps or aerator. This is how you control actuators on the fish farm. It can also output PWM on up to 16 channels, which is helpful for activities that need changeable control, such changing the speed of a DC motor or running a servo-driven fish feeder. Lastly, the ESP32 has two DAC channels that can make analog voltage, which let it work with devices that need precise analog control. Now, let's take a look at the communications interface. The ESP32 support IC, which let us connect multiple sensors using just two wires. It's really helpful for clean wiring. It also supports SPI, which we can use for things like SD card modules when we want to log data locally. Built-in Wi-Fi is the main way we send data to the cloud or a dashboard for remote monitoring. And with built-in Bluetooth, we can connect directly using a smartphone for setup or maintenance, and no internet needed. Let's move on to the capability and performance for the ESP Room 32. First, it's built to handle tough outdoor conditions. It can operate in temperature as low as minus 40 and up to 85 degrees Celsius. It also has built-in safety features like watchdog timers and brownout detection to automatically recover from any power issues. Next, it's super power efficient in deep sleep mode. It uses as little as 5 to 10 microamps, which is perfect for battery power setups. And it also has a low power core processor that keep an eye on things while the main system is asleep, only waking up when it needed. Finally, it has a dual core processor that let it multitask smoothly. One core can focus on reading sensors and handling control tasks, while the other manage Wi-Fi and communication. This means the system can react quickly to any important changes, like a sudden drop in oxygen levels. That's it for my part. Thank you.
In conclusion, the ESP32 is a great solution as a whole in the making of smart fish farming monitoring system. It has the ability to process various tasks simultaneously, in addition to supporting Wi-Fi capabilities that ensure a seamless flow of data. It also consumes minimal power, making it a great solution when battery replacement is not feasible, especially in outdoor environments where the system will be set to last longer. A smart fish farm solution is proposed that can monitor water parameters with the use of various sensors, automate the operation of aeration system as well as feeders. Since the ESP32 is capable of handling programming as well as communication function, this solution becomes much more effective and manageable. Apart from making a positive contribution to sustainable goals in the form of SDG 14, life below water. That's all from us. Thank you.